All right. Now that we have created all the beams we need in our model, we can collapse all the layers we don't need anymore. So just like this, and hide the master surface. We don't reference to that anymore. And now we are going to introduce a joint. So what is a joint? Basically, it's still a component, but it's a specific and a special component. Because as you can imagine, two components, two beams are meeting at a specific location. They create an intersection point. And what we want to do is we want to keep track of the information of those beams. So a joint contains the information about both parents. So if like beam 105 meets beam 206, we want to keep the reference to both of them. And in order to do that, you just like do the regular stuff. You stream components, you stream the component instances, you retrieve the reference axis, create the intersection point, and create a new component type. In that case, declare the parents, and yeah, just bake it. So after doing that, you get all the information in the model, like discussed here. So now you can also fill it with a placeholder. It's just synthetic sugar, but you see the joints more easily. So that's just a convention we do like this. All right. Now that we introduced the joint components and filled them with the placeholders, we actually want to extend them with some cutter geometries, because in the end, what the joints can do for us is to provide some information, some geometrical information that helps the beams crossing at that specific location, identifying which parts are getting operated, like cutters or whatever. Yeah? So we are going to fill them with live and information. First thing we need to do, this is more like a technical issue happening right now. If you set up this component, you need to recompute when using the same file in order to get the latest baked components. So when you find yourself like in that file, just bake them, just make sure to recompute, and then everything's fine. So what we do here, we create these cutters. Like same procedure as always, we stream the raw volume. We have a cluster here, and the output are some upper and lower cutters, which also get baked into our component. So let's just do that. Here we go. There we see some cutters. So I will hide the placeholders for now, and you see like just two cutters, the upper cutter and the lower cutter, and they will be used in the next grasshopper definition to cut holes into the according beams. All right, now that we defined our cutters, we actually want to create detailed volumes for our beams. So let's extend our layer tree again so that we see what's being created here. Like same stuff happening all the time. We stream our component types, we get the instances, in that case, the two different beam types and the joint. We get the upper and lower cutters of the joints, and we do some mapping here in order to do a Boolean operation, Boolean diff, between the raw volume and the cutters. And then we create a new layer, detailed volume, with a new geometry. So pretty straightforward. Just bake them, and you will see that there will be a new detailed volume. Here we go. I will just hide the other stuff. So I hide the raw volume and the joints. Zoom out a little bit, and yeah, maybe just let's look at the traversal beams. So yeah, you see, no, they are being cut actually with the information provided by the beam joint. Yeah, so that's it for the tutorial. I hope you find it interesting. If you have any questions, please don't hesitate to drop them below in the comments, or just reach out on GitHub per email or whatever you prefer to do. Wish you all the best and good luck. Enjoy using the tools, and see you soon. Ciao.